Hello, my name is Mason Dana, and I'm presenting my bioinformatics final presentation. I did this along with Christina Fennell. So we were analyzing SOX4. SOX4 is a transcription factor that allows for normal embryonic development. When SOX4 is mutated, it can cause degenerative disorders and even cancer. And the data collected came from exploring the impact of wild-type SOX transcription factor and SOX in its mutated form. So our methods. First, we downloaded the data from the NCBI website and imported it into RStudio so that we could analyze it. Numerical data was extracted from the provided data set. The means of SOX4 wild-type data and the CKO, which is just the mutated SOX4 gene data, were calculated, and box plots were created to determine the distribution of the data. Correlations between the wild-type and mutant genes were then determined to explore the similarities between the genes. We then did a t-test between each of the wild-type and mutant genes to determine the p-values and the statistical significance of the data. And then after that, we created histograms and a density curve to make, we did that to analyze a distribution of the p-values and q-values to verify that significance. So here are results. Here is a box plot of each sample analyzing the data. And because the data has been normalized, all of these box plots look extremely similar. And here is the data used to create the previous box plot. And as you can see, the numbers are very, very similar. So the difference between the minimum values is 0.002. So here is the correlation of wild type and mutant genes. Here, each gene was compared against the other and put into a table. So as you can see, when comparing wild type 20 to itself, there's a 1 correlation, meaning there's 100% correlation between the two. And then when you look at it compared to other genes, every gene is about 0.9 correlation. So that shows that each gene is very closely correlated to one another. So here is a histogram of the frequency of p-values and the distribution among the different genes in our set. And on top of it, we had a density curve, which shows that most of the p-values are between 0.1 and 0.2, meaning that most of the p-values that we calculated are actually not significant. Here is a histogram of the q-values that we calculated, and it shows that most of the q-values are just slightly below 0.6. Here is a distribution of the q-values, and this shows the minimum, median, mean, and max, and also the first and third quartile. Yeah. So here are the significant p-values. And in order to calculate this, we were analyzing the p-values from the first 50 genes in our data set. And so we only found 2 genes here that had any sort of significant p-values. And so this again shows that not very many of the p-values were significant, but this is only 50 out of like 15,000 different genes that were analyzed. So the significance of the p-values demonstrates that the SOX4 transcription factor does play an important role in the normal organismal development. Further analysis on other developmental genes along with SOX4 will, I think, eventually help regulate human development in the future. And here are references. And thank you so much for listening to me today. I hope you have a great day.